Hi everyone. From chapter 4 Combinatorics, I already discussed the basic of counting, permutation and combinations, binomial coefficient and identities, pigeonhole principle. Next I will discuss inclusion exclusion. I already discussed inclusion exclusion during set theory. What is principle of inclusion exclusion? The number of element in the union of two set is sum of the number of element in each set minus the element in their intersection. So it will be A union B cardinality equals to A cardinality plus B cardinality minus A intersection B. So this is the formula for principle of inclusion and exclusion. Let's see one example. Example 1. In a discrete mathematics class, every student is a major of computer science or mathematics or both. The number of students having computer science as a major is 25. The number of students having mathematics as major is 13, and the number of students majoring in both computer science and mathematics is 8. How many students are in this class? So let A for computer science, B for mathematics, and A intersection B for both, right? So A union B will be A cardinality plus B cardinality minus A intersection B. A cardinality equals to 25, B cardinality equals to 13, A intersection B cardinality equals to 8. 25 plus 13 minus 8, it's 30. So total 30 students are in the class. If we represent in Venn diagram, this will be the Venn diagram. This is for set A, set B. Set A is 25, set B is 13, then this part is A intersection B. What is common in both A and B? It's 8. Why we are subtracting? Because this part is repeating. It's in A, also it's in B, right? So one time we are subtracting. Let's see another example. Example 2. How many positive integers not exceeding 1000 are divisible by 7 or 11? Not exceeding 1000 means it will be between 1 to 1000. Okay. So let me take A is the set of positive integers not exceeding 1000 that are divisible by 7. B are the positive integers between 1000 that are divisible by 11. So A union B cardinality equals to A cardinality plus B cardinality minus A intersection B. How will find A cardinality? It will be simply 1000 divide 7 floor plus B cardinality will be 1000 divide 11 floor. Then A intersection B will be minus 1000 divide 7 multiplied 11. It's 77. It's floor function. So 1000 divide 7, it's 142. 1000 divide 11, it's 90. 1000 divide 77, it's 12. So 142 plus 90 minus 12 is 220. Answer is 220. There are 220 numbers between 1000 which are divisible by 7 or 11. So Venn diagram will be like this. This is for set A which are divisible by 7, set B which are divisible by 11. So A cardinality plus B cardinality minus A intersection B, that's 220. Let's see next example. Example 3. Suppose that there are 1807 freshmen at your school. Of these 453 are taking a course in computer science, 567 are taking a course in mathematics, and 299 are taking a course in both computer science and mathematics. How many are not taking course in either computer science or in mathematics? Okay, so first we need to find the union, and that we need to subtract from this. Then only we can find how many are not taking. So let A is the freshman taking course in computer science and B is the freshman taking course in mathematics. So here A equals to 453, B equals to 567, and A intersection B equals to 299. A union B cardinality will be A cardinality plus B cardinality minus A intersection B. So 453 plus 567 minus 299 is 721. So total how many students? 1807. From that 721 are taking course either in computer science or mathematics. So you can subtract that. 1807 minus 721, it's 1086. There are 1086 students who are not taking course in either computer science or mathematics. You can draw the Venn diagram like this. Let this is 1807 all student. Then from that this is A, this is B, and this is the intersection. A is the student who are taking part in computer science, B is the student who are taking part in mathematics, right? And we found A union B equals to, this whole is 7 to 1. So you can subtract 7 to 1 from 1807. So this rest part is 1086. Okay. Till now it did for two elements. If there will be three elements, then what will be formula? Like A union B union C cardinality will be A cardinality plus B cardinality plus C cardinality minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. So this is the Venn diagram for three set, right? A, B, C. So first we need to add A plus B plus C, then minus 2 to intersection, then plus 3 intersection, right? Example 4, a total of 1, 2, 3, 2 students have taken a course in Spanish, then 8, 7, 9 have taken a course in French, and 114 have taken a course in Russian. Further, 103 have taken a course in the both Spanish and French, 23 have taken course in both Spanish and Russian, 14 have taken course in both French and Russian. If 2092 students have taken at least one of the Spanish, French and Russian, how many students have taken a course in all of the three languages? So let S for Spanish, then F for French and R for Russian. Okay, and here S equals to 1232, F equals to 879, R equals to 114, S intersection F is 103, then S intersection R equals to 23, and F intersection R equals to 14, and S union F union R equals to 2092. So S union F union R equals to S cardinality plus F cardinality plus R cardinality minus 2 to intersection. So S intersection F minus S intersection R minus F intersection R plus 3 intersection. So S intersection F intersection R. We don't know this value. We have S union F union R, that is 2092. Now substitute all the value. 2092 equals to 1232 plus 879 plus 114 minus 103 minus 23 minus 14 plus S intersection F intersection R. Now solve this. Okay, just find the value and take to left side, subtract from 2092. So S intersection F intersection R equals to 7. So there are total 7 students who take course in all three language. Okay, if we'll take Venn diagram will look like this: S for Spanish, F for French, R for Russian, and this is S intersection R, S intersection F, F intersection R. This S intersection F intersection R, that cross of all, right? So this example was for 3 set. Okay, if there are more set like 4, 5, 6 or more 10, then what we'll do? So there is a formula for all, like let A1, A2, AN are the finite set. Then A1 union A2 union AN, that will be sum of AI, I range between 1 to n, minus AI intersection AJ, this I and J range between 1 to n, plus AI intersection AJ intersection AK, this I, J, K range between 1 to n, minus 1 power n plus 1, A1 intersection A2 intersection till AN. So first we will add each individual set, minus 2 to intersection set plus 3 intersection set minus 4 intersection set, then plus 5th intersection set, like this it will continue. 1 minus 1 plus, right? So let me write formula for 4 set. Let we have 4 set A, B, C, D. So A union B union C union D. A cardinality plus B cardinality plus C cardinality plus D cardinality. So addition of all single set minus A intersection B minus A intersection C minus A intersection D minus B intersection C minus B intersection D minus C intersection D. So minus of all 2 to intersection. Next we'll do plus, right? A intersection B intersection C plus A intersection B intersection D plus A intersection C intersection D plus B intersection C intersection D minus A intersection B intersection C intersection D. So this will be a formula when we have 4 set. Like this you can write for 5 set, 6 set, 7 set for any number of sets. In today's lecture I discussed inclusion exclusion formula with some example. In next lecture I will discuss recurrence relation. If this lecture is helpful for you, please like, share and subscribe. Thank you.